Welcome back to AB Shop. In this video I will show you an important part of my workshop, my milling machine. So let me show you my milling machine SX3. This is the datasheet that we can find of my milling machine. Okay, it's right in German, but the translation is 15 millimeters. This is the big diameter that you can use with an end mill, but not an end mill that go down from solid, but an end mill that is used to make something plain. So okay for the diameter, but you can cut like 0.5 or 0.3 millimeter for every passage, sorry, no more with this diameter. These lines means the big drill bit that can be installed and that can be used for drill forms from solid. Usually if I have to make a hole of 25 before I make 2 or 3 holes, like a guide for the drill bit. This is the big diameter also for the end mill that you can use. This is yes from solid. So if you want to make a deep hole with an end mill from solid, you can install 25 millimeters. This line means the maximum tap that can be used. Okay, if you want to use the motor in the steel, you can use this, but there is also some other possibility to use also bigger tap with an end tool that maybe after I show you. This is the tape of Spindle. Is right ISO 13, and commercial tape is NT13. NT13 is ISO 13. Is a special spindle that after I will show you. This is the RPM, the velocity, the revolution per minute, from minimum of 100 to a maximum of 1750 RPM. This is the motor there is inside of the head. It's a brushless motor, so no problem with the torque. You have all the torque for sure of the maximum value at every RPM, and the power that is installed of on the head is 1 kilowatt, so 1000 watt, and this is the frequency, so 230 volt and 50 hertz. This is my milling machine. It's a Next SX3. It's made in China from Shanghai, and this model have a weight of 550 kilos. It's a vertical machine, like you see. There is a head in the upside, and with the spindle and the brushless motor inside the head. There is the column, the DRO that come like a kit, like an optional, and this is the table that have also on the left the power feed for the X-axis. And this is the head in the front side, as you can see from the top. This is the start stop and also the emergency. What is right here is the RPM, and this is for going up and down with the velocity. This is to start, this is to stop. This is right or left, this is the direction of the revolution for the spindle. And this one is for the tapping mode that after I will show you. Here we have a caliper. This caliper you can put on. Is used for showing the depth. So you can see that I go down, and so I go down the spindle, and there is a spring that reports the spindle on this diameter. You can put, you can also make 0. You can go down, okay, you see with this caliper where you are, okay. And this is the protection that you can lock like this. You can lock also the spindle in this possibility, so you can close this one and you lock the spindle in the position and unlock. Okay, and this is for start. Okay, we have closed the protection, so there is a micro that say okay, you can start. This is 100 revolution per minute. You cannot hear nothing because it's very silent. In fact, the transmission from the motor to the spindle axis is made by a belt, a tooth belt, not by gear. This is the buzzer that I don't like. Of course, there is something that I don't like, and the buzzer is something that I don't like. So you can make something like this, or you can put. Now we are at 1070 RPM. Is the most noise that you can hear from this machine. So I have to say you that it is very silent because I can use in the early morning with no noise, and of course for this I'm very happy. This is the stop and we close. Okay, and so now we can see another part of the head of my milling machine. And okay, we have the handle to go down, okay, for make drill, and also we have this handle, this hand wheel that is used to make the fine rolling down of the Z axis. I don't have the motor to rolling down, can make only like this, like a drill pillar, or you can make in this manner. This hand wheel is very useful because as you can see, you can stop the hand at 1/8, for example. This is used when you want to make, for example, the 0 here, 0 here, 0 here, and after you rotate the hand wheel in the other direction and also the chuck return. But also if you close, this is what I really like of my machine. If you close this like this became active, and as you can see from here, when you go down you have the possibility to have the, sorry, is in the other direction. You have, as you can see, the possibility to have the depth that is also showing in this point, and as you can move, you can see that the Z axis go down, and if you open the hand wheel, so unclockwise, it returns to the position. Now I want to show you the tapping mode. Tapping mode in this machine is something of fantastic from my point of view, because it's very easy to use and very useful, and you can make everything without no problem. This morning I was making this head, and it is an M4. You have only to make the drill and the tap in the vertical, no problem. And I can show you. So first of all, you have to make the start of the spindle that in this moment is at 550 RPM. That is too much to make tapping, and so you have to go down. Usually I use a velocity of 130, 140 RPM, no more. So you have to make this. After you have to activate this one. You can see that there is a LED that is a flashlight that is became red, and this means that these buttons in this moment are working. And so, for example, if you have a part that have to be tapping, you can see that you go down, and now, for example, it's tapping. When you arrive at the depth that you want, you push and you go up. You have only to gently go up with the hand, and when you are out of the piece, you repeat and you put in another time the revolution of the spindle, and so you have finished. You have only to repush. In this moment we are out of the tapping mode and stop. So it's very useful and work very well. This is the end wheel that I have on my milling machine. This end wheel is for the Y axis. So now, of course, it's closed because I was working on. Okay, so this is the Y. And on the right, this is the X axis, as you can see also from the DRO on the right. And this is for the head. So if you want to go up, you can see that the chuck is going up, or you go down. Okay, in this moment is going down. Okay, this is the power feed for the X axis. The milling machine, when I bought 1 year ago, it's arrived without this, so it's a kit. This is the code of the kit. It's very easy to install. There is a joint here, and there is also this one that you have to screw on the table, but is really easy to make. Okay, when the kit arrive also this limit switch that is from right to left. So when this one that is attached to the table arrive here, there is this button that communicate to the power feed to stop. The power feed is command with this level from left and right, for example like this. And this is the potentiometer. So I don't have a number that represents the velocity of the power feed. So you have to use and to try to see if, for example, the finish of the surface is correct or not. But there is also another tricky when the velocity is too much. And the tricky is this. You have, for example, to close something, the table, to have a low velocity, and you open if you want the high velocity. Okay, to start you have to rotate this one, and to make you have to move a little. Okay, now it's ready to go, and I can show you. You can see that it's moving from left to right. This is the minimum velocity. The other direction. You can also go to the high velocity if you want to move, and when you were to work, you can go down to the low velocity and after stop. If you don't want to use it, you have only to remember to disassembly or disconnect this, because otherwise there is the possibility to break or to make something that is not good. So you have only to go up, and now is disengage. This is the DIO. The DIO that I have is showing the X axis, the Y, the Y, sorry, axis, and the Z. Okay, so when you move the X, for example like this, you can touch the piece. In that case you will be in that point the 0, so you can push the 0. For example, we move the Y, the Y axis, and for example this in this moment the drill bit are touching the part, so you put 0 and you have the 0 position. But if you want to take another piece, you don't have the 0, there is many other options. For example, we make an example, we have to make the 0 of these parts. Okay, we know that the 0 is in the center, but now we have in the hand, so we don't have the 0. We go down to the vise, and of course we can say that, for example, this holes is at minus 10 plus 10, and so 10 and 10 in X and Y. So we put in the vise, we center a drill in this point, and after we go on the DRO and we say X 10 and enter. We say that the Y point is also 10, so Y, you write 10 and enter, and so now you are in the position of 10, for example 10 in X and Y. So the only possibility that you have is to go now to the 0. For example, we say that the 0 is 0 and 0, so you go to the 0 like this. You go to the 0, it's not 0, okay, but I want to say you 0. You go to 0 like this, and you are in the center. Okay, now we make another example of how to use the DRO. Of course, the DRO is very useful when you want to make something in a very precious mode like this one. You must only have the coordinate X and Y, and you can make what you want, okay, like this. But of course, it's easy, for example, to find a point that you cannot find in other manner. For example, we want to find the center of this round bar. Okay, you can make, for example, in the lathe a small center, but for example, we don't want to have a center here. We want a nice surface, so we have to find the center. To find the center, I usually use this old style edge finder. Okay, maybe you know is out of center, but when he touch and go in the center, this means that is touching, and so you have to make the 0. Now I show you how easy it is to find with this one and also with the DRO the center of this round bar. So we go in the chuck, we go in the center like this. Okay, the machine is ready. We go up to 300, no more. Okay, we go outside center like this, and we go down. We can go down with all the head, or like I show you, we can go down only like this. So for example, we go here, okay, and now we move in the x-axis until the out of center is touching the piece. So now it's touching. It's not parallel until now. And yeah, now yes. And we say 0 to the x-axis. Okay, we go up, we move. Okay, you can also use the power fit. And we go to the other side. We go down and we repeat. So we go out of center, we move, we touch, okay, until is perpendicular, and you can see that is rotating in a round mode and perfect in the vertical, so axis with axis in the same point. And we read in the x-axis. We say that in the x-axis is right 16.790. So with the calculator 16.790. We divide plus 2 and we obtain 13.3395. Okay, so now we go in the point 13.395, 13.339 and 5. We can close here and we say 0. Now we repeat for the y-axis. Okay, so we are in this moment in the 0 in the x-axis. Only the x-axis is in the 0. So we go down here. Okay, like this. We go down. We move like this, and until he touch in the parallel mode, like this, and we say 0. We go to the other side. The x-axis is okay. Now out of center. Okay, we go down like before. Okay, we touch until he became parallel. Now it's parallel, and right is 64.510. So 64.510. Okay, like this. Divide plus 2 is 32.255. And so we go up. We go to 32. You can see the y-axis. 32. Sorry, 0.2255. Yeah, 255. Okay, we close. This is okay. Okay, perfect. And we say 0. So now we are in the 0. We are perfect, as you can see, in the 0 of the parts. Sorry, you can see here that we are in the center, and this is our 0, 0. Okay, so if you want to drill to find all that you want, now you are in the 0, 0 of the part that you are working on. And to finish my explanation, I can show you also that there is a basement that from my point of view is also well done, because here there is the chip table, so all the chips that rolling down from the table is collected here, and they didn't roll into the downside, so it's easy to collect and also to clean. There is this that is a space. You can see here inside there is everything. As I said before, this is the tape of the chuck that my milling machine have. You can see is the NT13. NT13 is a special spindle, as you can see. It's like a Morse, but it didn't work like a Morse. The Morse spindle is work with the torque, transmit the torque, and also the cone is for centering. In this case, the cone it is only for centering, because the torque are transmitted by these two tooths. So it's very different. So you have only to put up to close the drawbar, and the torque is transmitted here by two dents. Okay, this is for the spring. You can see, I don't know if you can read here is ISO 13, and this is the ER32. Okay, you can find this with the name ISO 13, but also NT13 is the same. But also there is this space as you can see here. Now I try to show you. Okay, and here you can put many other parts. So the basement is very well done, and the sheet metal that is used have a thickness of 3 millimeters, so it's strong. Explanation. I want to show you how to change the spindle. The spindle is as you can see, as I said, in NF13, and is connected to the spindle of the machine by a drawbar that starts from this point and arrive here. So the manual said to unscrew this cap. Now I will show you. Unscrew this one, unscrew this, and with a soft hammer push down the chunk. But I don't really like to use an hammer where you have the bearings. Also because the bearings that are here and here is conical, is something of special bearings. I don't like to use the hammer. And so I make this spacer. I don't know if you can see here, that is white. Why? Because when you unscrew this, the spacer will go up to touch the inside of this cap, and so the force go down, and this is used to disengage the force in the cone, okay, that is only for centering, and also to disengage the spindle. Now I show you. So we make like this, we remake the cap, we stop the spindle in this and we unscrew, okay, like this. Now in this moment the spacer is touching, so with the screw that is the 16, stop. Okay, this clonch is the noise that say to you that the spindle is ready to unscrew. Okay, and you can change the spindle. Okay, the drawbar is connected here. If you want to remake another spindle at the same time, you make like this, close the drawbar like this, and re-put the cap. So the time to change a spindle from, for example, for drill bit to the other one that is for the end mill is less than a minute. Okay, we have finished the explanation of my milling machine. I hope you like it and you enjoyed my video. So thanks for watching, and we will see at the next time. AB Shop.